Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 4, Lesson 3 on constructing translations. Now, before we even get into this lesson, might I just say that in order to construct a translation, you have to know how to do two things really well. How to copy an angle and how to construct a line parallel to a given line through a point that doesn't lie on that line. All right, those two are going to be essential for what we do today, and we did those. For us, we did those in Unit 4, Lesson 2, so just the lesson right before this one. Make sure you know how to do that. We will review how to construct a parallel line here, but it's going to be very important when constructing translations. So let's get right into it. Right? Translations. Now recall that a translation moves points by a certain distance in a certain direction in the plane. The direction is defined using a vector. So let's take a look at exercise number 1. We want to translate point C along a vector that points from point A to point B shown. Letter A. Construct a line through point C that is parallel to AB. Leave all construction marks. Okay, great. So let's review how to construct a line that goes through point C that is parallel to the line that goes through A and B. Now remember, the first thing I want to do is I want to actually create an angle, strangely enough. I need to create something that goes through a line that goes through point C that also intersects the line that I care about. And you could actually make it go through point A if you really wanted to. I'm not going to do that. I'm just going to kind of draw a line that passes through C and intersects the line that goes between A and B somewhere. All right. Now all that does is it creates an angle here that I'm going to try to then reproduce here. That's all. I just want to reproduce this angle at vertex C. Okay, so let's remember how to reproduce an angle. I'm going to bring my compass over and put the sharp end down at the vertex of the angle that I know, and I'm going to just simply open up the compass to a certain length and draw an arc of a certain radius. Okay? Now, without changing that compass length, I want to bring over and put the sharp point of the compass on C and sort of reproduce an arc that has the same radius as what I just did. Okay? Right, that's step 1 in copying an angle. Now what I want to do is I want to set the compass length to be the length between this intersection point and this intersection point. Okay, so here we go. I'm going to actually measure it from here, all right, up to here. So let me just see how close I am. That's pretty close. I think I need to make it just a little bit closer in. I'm not going to get any closer. Oof, man, that's pretty far off. But it's the best I'm probably going to do right now. I'm going to bring this over here, and I'm going to reproduce that right there. Again, my apologies for having it a little bit off. That was gorgeous. That's my compass doing the splits. All right. Now, had I made those arcs perfect, or that one arc perfect, then when I now draw the line that passes through point C and the intersection point that I care about, that line will be parallel to line AB, and it's not too far off. Again, just a little bit of a problem with the electronic compass up here. I really want that arc to have a starting point here and an ending point where the original arc hit that ray. Okay, now in theory, the line that I constructed is parallel to vector AB. So let's see what we do next. Let me just move this like this, get this kind of out of the way so that we can actually read what's in C. Let's take a look at C. Use the distance from, B. Use your compass to mark the distance from point A to point B. Now, okay, remember, a vector is all about two things, direction and distance. So we now have the direction, right, of the vector, but we also want to know the distance. So I'm going to bring my compass over here. I'm going to put the sharp end on point A, and I'm going to open up the compass so that it's got a length of AB, of that vector, right? That's almost there. Let me get it better. There. Ah, not bad. Now remember, when I measure that distance, I want to mark it off on my diagram. Now that's all I was asked to do in letter B. Now let's take a look at letter C. Use the distance from B to determine where the image of point C should be along the line you constructed in A. Mark the image C prime. All right, so this line defines the direction of the vector. This now defines the length of the vector. So I can now bring this over, put it on point C, and use it to determine where C prime should go. And there we have it, right? We have now moved C, or translated C, both in the same direction as the vector and in the same distance as the vector. And that's it. That is a translation. All right, same direction equals parallel. To move in the same direction will be defined as moving parallel to the vector that defines a translation. Parallel line constructions are key to constructing translations. In fact, they're the hardest part of constructing a translation. The final piece is just measuring how long the translation is, and we do that with a single arc, right? So let's get a little practice at translating a point a certain distance. Exercise number 2. Using only a straight edge and compass, construct a translation that maps point G to point G prime along a vector that points from point E to point F. All right, so here we've got this line, right? It contains point E, it contains point F. I want to just take G and I want to move it along a vector, right, that is the same length as the vector that goes from E to F, right? And it's in the same direction. So the first thing I want to do is construct a line that is parallel to line EF that passes through point G. Let's do it. Simple enough, right? The first thing I'm going to do is I'm going to draw a line through G that intersects the line that I want to be parallel to. Okay, move that out, right? I now want to copy that angle. You're probably getting tired of hearing about this construction. I'm going to copy that angle by opening up my compass and trying to get the point more on that vertex. Let me move that out of the way. I'm going to draw myself an arc, right? I'm going to then move my compass up to point G, and I'm going to construct the same arc. I'm going to try to get my compass on point G and draw a similar arc, right? I now want to measure the distance between the arc, between the two intersection points of the arc and the ray. Oh, that's very close. Let me get it a little bit tighter and try to get that point back on that. Ah, so close. There we go. Measure that. That's perfect. Bring that up to this intersection point. Measure it again. X marks the spot. And now I simply need to draw a line that passes through G and passes through that intersection point. All right. And we want to make it nice and long. Okay, so let's pause just for a minute. All I did here was exactly what we did in the last lesson, where we created a line that was parallel to a given line and passed through a given point. Now what I want to do is I want to move point G along that line exactly the same distance that it would take to move E to point F. The way that I measure that distance, as always, is with my friend, right, the compass. So I'm going to bring this thing out. I'm going to open it up so that it is the length of segment EF. I'm going to mark that length on my paper. I'm going to bring the compass up, put the point on G. I'm going to then mark the distance again. The job of my compass is now done, and that will be G prime. That's it, right? It's really one additional step over what we did in the last lesson, where we were constructing parallel lines. Now, of course, constructing parallel lines is sort of one additional step over copying an angle, okay? So copying angles lead to parallel lines. Parallel lines then can be used to create a translation. All right, let's keep going. Now, we can certainly translate geometric objects. So far, all we've done is translate points, right? Now, we can translate geometric objects such as lines, angles, and figures like triangles, quadrilaterals, etc. Okay? Let's take a look at exercise 3 where we do something like that. In the diagram below, translate line MN such that point M is mapped to point P and point N is mapped to point Q. Leave all construction marks. Draw line PQ. Okay, this is cool. So in other words, I want to take this line and I want to translate it. Okay, but I have to in some way define the vector that you're supposed to translate along. So I'm just saying, look, I need you to translate M, the whole line, so that M gets mapped to P and all other points get mapped using the same vector. So the first thing I'm going to do in a situation like this is I'm actually going to set up the vector itself. Or better yet, I'm going to draw a line through points M and P just to simply establish sort of the direction of my vector, okay? I have to kind of have something like this, right? Now, I've got my vector, right? I'm really back to my last problem, right? Here I've got my vector, or at least my vector is what points from M to P. I now need to create a line, okay? I now need to create a line that passes through N that is parallel to this particular vector. Now, in the past problem, what I did is I had to draw a line from N that intersected this thing. Well, I already have it here, all right? All I need to do is now copy that angle at point N, right? That's all I have to do. Copy the angle that already exists at point N. So here comes my copying the angle construction again. We're copying lots of angles in this particular lesson, right? Bring my compass over, rotate it down, open it up some, get the point back on M again, draw an arc, right? Very carefully, bring it over here. Oh, that's not going to be quite long enough. We're gonna extend that in just a moment. All right, because I've got to have that long enough. Now, things like that happen all the time, by the way, right? I simply made an arc that was a bit too long. Well, that's okay, because I can construct or I can extend any line I ever want, okay? So I'm just going to extend this a little bit further so I get that intersection point. Now remember, I'm going to come here and I'm going to measure the distance from one intersection point of the arc to the other intersection point. So roughly like that. Oh, that looks pretty good. There we go. Not perfect, but it'll do. Now I'm going to come over here. Same deal if I can. And there we have it. That's it for now for my compass, not forever. We'll come back to you, compass, don't worry. Okay, now we're going to draw a line through N and that intersection point. Hopefully get that rotated just a bit more. Okay. Maybe extend it a little bit farther just to make sure it's long enough. Okay, so now we've got those two parallel lines, right? Now I just have to measure the length of the vector that goes from M to P, as always, right? With my compass. I measure the length, open it up. That's pretty good. Excellent. Bring it down to here. Measure the same distance. And now I have guaranteed to translate point N, and I think it was supposed to be to point Q. I've now translated point N in the same distance, in the same direction as what it would take to translate M to P. Right, now I just want to draw this line. Looks pretty good. And there is line PQ. All right, there we have it. Now again, this one was a little bit different because oftentimes we've got the vector and we've got the point, right? And then we have to first start by drawing this line in, but that line was already there, right? So all I had to do was reproduce this angle here, those corresponding angles, right? That then produced a line here that was parallel to the one that I drew in, right? Using that, I could then measure off the distance that I needed to translate the point, and then I could draw the line through the 2 points, right? Giving me the image line compared to the original. Now there's a little bit of a follow-up on this one, right? This reviews something that we saw back in our unit on transformations, okay? Let's get this out of the way. Let's take a look at exercise number 4. What is the relationship between line MN and line PQ from exercise number 3? Okay, so in other words, here's that construction reproduced down here a little bit neater. What is the relationship between line MN and its image line PQ? Pause the video now and tell me if you can write something down. All right, well, they're parallel. All right. All right. And remember, we saw that back in our unit on transformations. Translations had this really cool property where if you had any line and you translated the line in a direction not parallel to the line, then the image line was always parallel to the original line. So this particular line, right, which is the image of MN, will be parallel to it. Whenever you translate a line, its image will be parallel to the original. Again, assuming you're not taking the line and then just like sort of translating it along the direction of the line. That's the only case where you don't get a parallel line, you just get the same line. Okay, so now let's do a tough one, or at least what I think is going to be a tricky one. Let's take a look at exercise number 5. Using only a straight edge and compass, construct triangle DEF, which is a translation of triangle ABC, along a vector that maps point A to point D. Leave all construction marks. This will take some time! Exclamation point. All right, so just to make sure you understand, what I want to do is I want to take this triangle and I just want to translate it over so that point A maps to point D, right? And then point C and point B get mapped to wherever they're going, E and F respectively, using the exact same vector that I used to translate A to D. Now the first thing I want to do in this situation is I want to establish the direction of the translation. And the direction of the translation is going to be the direction of the line that passes through A and D. So that's the first thing I'm going to do. I'm going to just draw a line between or through, not really between, but through points A and D. All right, so that I've got that direction down, right? It's all about parallelism. So this defines everything now, right? Every one of my translations now, and there's just going to be 2 of them. I need to translate point B, I need to translate point C, right? All of my translations now will be parallel to that line. And I think the first thing I'm going to do personally is I'd like to translate point C. I know it's kind of weird. You'd probably think, oh, start with point B. I'm going to translate point C. Now again, remember, I need to construct a line that passes through point C that is parallel to line AD. Okay? Which really means I want to reproduce this angle, this particular angle down here. Well, the first thing I'm going to do is actually extend side AC. All right, I'm going to make that longer. All right, otherwise I actually can't reproduce that angle, right? So I need to actually kind of extend this and make it longer. No big deal. I can do that. I can extend any line I want. Now what I want to do is I want to reproduce, right? I want to reproduce that angle whose vertex is at A. Whoops, wow. I want to reproduce that angle, but at C. So as always, I come up to A, open my compass up, I create an arc that passes through the 2 rays of that angle. Without changing the radius of that arc, I bring it down, I put the tip at C, and I draw the same arc. I'm now going to come up and I'm going to measure the distance between those 2 arcs intersections. Close. There we go. Pretty good. Come on. There it is. Oh, not the greatest. That's disappointing. All right. There we are. Okay, that's all I will need the compass for just for the time being. right? That should allow me to create this parallel line between those 2 points. All right, now, if I've done it right, and yeah, it's questionable, right? The line I just drew should be parallel to that translation line. Now all I need to do is measure the distance of the translation, right? The distance from point A to point D. Simple enough. Maybe turn my compass upside down and flip it a little bit. I'm going to put my pointy end at A. I guess I could also put it at D. It really wouldn't matter. I just need to figure out what that distance is, so I got to extend it a little bit further. That looks good. Overshot it a little bit. That's okay. Bring it down here. Mark the same, and I now know where C gets translated to. I just can't move my compass. Oh well. We'll get it in just a second. All right, so that's where C gets translated to. By the way, where should C be mapped to? It should be mapped to point F. So that's point F. Okay, great. Wow. All right. Now I have to figure out where B gets mapped to. And it's really going to be the same song, second verse, right? So what I'm now going to do is I'm going to extend line segment AB. All right, so I'll take line segment AB and I'll extend it. I just find this to be the more complicated one because the angle I'm going to have to construct will be obtuse. Not that that makes it really any more difficult, but right, I'm going to extend line B. And now, I just really want to talk about this for a moment because I think that the picture can get complicated enough that it gets quite confusing. So let's chat about this for a second. Before, I was trying to reproduce this particular angle. Now, I need to reproduce this angle. All right, I want to reproduce that angle down here at B. And one of the things that I find personally the hardest is that you really have to ignore line segment BC. It has nothing to do with this. I'm trying to reproduce this obtuse angle at point B, line segment BC, totally irrelevant, okay? So let's do that. Let's reproduce that obtuse angle in red down here at B. All right, now I'm still going to do exactly the same thing I did whenever I reproduce angles, which is I'm going to take my compass, I'm going to put it at A, and I'm going to draw an arc. Now, what I did in this particular problem actually is I literally just kind of used the same arc I did in the first construction, or at least I tried to use the same arc, but didn't quite pull it off. All right, anyway, it doesn't really matter, right? I'm going to bring it down here. Now again, I'm not worrying about BC, right? I'm just trying to create that big arc like that. BC is irrelevant. Now I'm going to be measuring the distance that this large arc is. Okay, I just got to make sure I get the right one. That's why I kind of wanted it to be the same one. That's actually pretty good right there, right? Just measuring that distance, bringing it down to here, and doing the same thing, right? We're going to put our compass away just for the time being, right? X marks the spot now. Whoops, oh my goodness. That just got real messy. Okay. X marks the spot. Sorry about that. Now I can draw a line that passes through B and goes through that intersection point. And of course I made it red just to make things very confusing. Okay, maybe go back to blue. All right, or maybe I should leave it in red. I don't know. Anyway, so again, if I've done everything right, that line now in red should be parallel to the line that passes through A and D, and of course should also be parallel to the line that passes through C and F. We just, again, need to measure the distance from A to D. So let's do it. We gotta just set that compass length one more time, and then we're basically done with probably one of the harder constructions we ever do. All right, if only we could get it to be the exact length. That's gonna be as close as we're gonna get. We're gonna bring it down here. Measure that same length. Now we're really truly done with our compass. That's now going to be point E. We now need to just connect our 3 points and we will be done. Here we go. Right, there's DF. There is DE. And I just have to be careful, right? And here is EF. Oh, it so desperately wants to snap there. Okay. And there we've done it. Isn't that a cool picture? I mean, it's very messy, I get. But again, all we've done is we first originally defined the direction that we're moving in, create two lines that are parallel to that pass through the two vertices that we need to translate. We don't need to translate A, its image is already there. Then we measure the distance from A to D, mark it along those two parallel lines, and that then gives us our translated triangle. Awesome. One last little piece on this that I think is actually quite visually cool. Let me move this out of the way. Here is that construction again, okay, in all its glory, but without all the color. Let's take a look at exercise number 6. A parallelogram is a four-sided figure, a quadrilateral, that has two pairs of opposite sides that are parallel. Name all parallelograms in the figure above. There's actually quite a few parallelograms here, okay? And that's because, right, think about this, right? We know AD is parallel to CF is parallel to BE, right? We talked about that. But we also know that the image of any given segment on the original triangle will be parallel to its image segment on the final triangle. So for instance, AB, right, is parallel to DE because all DE is a translation of AB, right, across that vector. Likewise, right, EF is going to be parallel to BC because it's just a translation of BC, and the same thing can then be said about AC and DF. They're all parallel to each other. So see if you can name the there are 3 parallelograms in here. See if you can name them. All right. Well, when naming four-sided figures, all you have to do is grab one vertex and either move clockwise around it or counterclockwise around it and name it all out. So for me, one of the most obvious parallelograms is ADEB. ADEB. And to help you visualize that one a little bit, it's right there. Oh, sorry, ADEB. Oh man, here I just explained how to name them and then I misnamed it. ADEB. Thank you, Joey, my producer. He caught that mistake. Great. So that's one of the parallelograms. I think the other two are a little bit harder to see, but you've also got one here that goes from B, E, F, C. So B, E, F, C. And let's see if I can hit that one right. There it is, outlined in purple, right? And the final one is A, D, F, C, right? It's kind of like, oh, the thing that's laying here, right? A, D, F, C. And that should be right there, right? Our 3 parallelograms. 1, 2, and 3, right? Parallel lines all over the place in translation diagrams like this, because not only are you translating parallel to whatever vector you have, but then every image segment is parallel to its pre-image segment. Kind of cool, huh? All right, let's wrap this up. So really today we almost didn't learn a new construction, right? Because by far and large what we were doing today was the parallel line construction. The translation piece of it was just measuring off the distance that we actually translated a point. That was it, right? So if you know how to construct a parallel line through a point, then you should also be able to construct a translation because it's just one step further. Now granted, some of these constructions can get quite complicated like that last one, but in general, they're fairly easy. All right, we'll see more of these things as we move on in Unit 4. For now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.